Today, we're taking a trip back to conics. All right, here in your warm-up, I have written the standard form of different conics that have been shifted. I want you to try to match up the equation with which conic you think it is. Let's recall that a circle is also a conic. I didn't put a lot of information about circles because they are much simpler. They are just ellipses whose center is also their foci. All right, so you've got ellipse, hyperbola, parabola, and circle. Go ahead and pause the video here and see if you can match up the equations. Okay, let's go over them. So take a look at this one. You have the quantity y minus k is being squared, but nothing over here in the x's is being squared. That means it's a parabola and you are opening to the left or right. So this shifted conic goes with that one. Okay, and then of course this one is a circle. When you have a minus in between, that is a hyperbola. Okay, so the hyperbola that has x first, that one opens up and down, so that one's gonna go to this one. And the one that has y first, y over the a squared, that one opens left and right. When you have a plus sign, you have an ellipse. This ellipse, the a squared is under the x, so this one's opening. This one has a horizontal axis. And then you have where a squared is under the y, so vertical axis. And then again, another parabola, except the x is being squared. So this one's actually going up and down. We're gonna go ahead and graph this particular conic. First of all, what conic is this? Well, we've got a plus sign here, we've got a squared quantity and a squared quantity, and it's equal to 1. That would be an ellipse. So what's the base ellipse that we're looking at, the non-shifted ellipse? That would be x squared over 4 plus y squared over 9 equals 1. And I want us to remember how to get the specific things here, foci and vertices. Okay. So with an ellipse, the bigger number is the a squared. So a squared is 9, that means b squared is 4, and to get c squared, we do a squared minus b squared. Well, 9 minus 4 is 5. So now we have c squared. That gives us vertices, co-vertices, and foci. Since a is under the y quantity, then our ellipse will be long ways. Okay, it will have a vertical axis. These are its vertices, co-vertices, and foci when we square root. But how do we get the shifted pieces? This equation here, HK is the center of whatever conic we're kind of looking at. So the center is HK, that would be -1, 2. So what is happening to all the xy values of our base ellipse? Well, each x will subtract 1, and each y will add 2. So we're going to actually show those transformations, starting off with the vertices. 0, +3. That translates to be 0 minus 1, comma y is 3, so 3 plus 2. Oh, okay, so your vertex, one of your vertices is -1, 5. We do that with the negative version, the negative vertex, so that would be 0 minus 1, and negative 3 plus 5, which is negative 1, 2. My bad, we should not have added 5, because what does our formula say? Our formula says that each original xy value should do that particular shift, adding 2. So that would be a negative 1. I knew that did not feel right. Okay, go ahead and do that to the covertices and the foci. Go ahead and check to make sure that these are the points you ended up getting, and then let's plot them. Wow, there's my beautiful ellipse. Now algebra, all this algebra you don't have to do, because you could have looked at this ellipse and been like, hey, I know the center is HK, I know that it's going to go square root 9 up and down from the center, and it's going to go square root 4 left and right of the center. Really, the only thing that you have to really do the algebra for is finding C to get you the focus of the base ellipse, and then transform that. Okay, so we did this kind of a long way so that you could see the algebraic way in case you're not visualizing it or remembering all the pieces of conics. All right, and then there's actually General Conic Form is what it's called, general equation of a shifted conic. Okay, so what we've been working with so far is standard form, but all conics, and the reason why they're so related, right, is because they could be written in this General Conic Form right here. Okay, and that gives you some pieces of information that if the parabola, it's a parabola if A or C is 0, it's an ellipse if A and C have the same sign, or if A equals C, then it's a circle, and then it's a hyperbola if A and C have opposite signs. So that's also good to know when you're looking at the General Conic Form, but also changing it into standard form can help us, and we're just going to practice doing that by completing the square. Look at number 2. Do you know which conic it is? Well, let's see if your prediction is right. We need to complete the square, so we'll first have group all of your similar variables, so minus 14x. Then I'm going to leave a space for completing the square, and then I have plus y plus 45 equals 0. Oh, y squared is equal to 0. When c, the coefficient for y squared, is equal to 0, we have a parabola. So you already know what kind of conic you have, but let's continue to change it into standard form. We are going to add negative 14 divided by 2 is negative 7. Negative 7 squared is 49. We're going to add 49 to both sides. Okay, this trinomial is a perfect square trinomial. It factors to be x minus 7 quantity squared. And then we have plus y plus 45 equals 49. Hey, when it comes to a parabola, the standard form has the quantity that's being squared isolated. So move everything else to the right side of the equation. Negative y plus 3. And so we're going to factor out this negative so that it's y plus or minus some quantity. Negative y minus 3. And yes, indeed, we have either an up or down facing parabola. Actually, this sign right here tells us that it faces down. Let's try this one. Do you have a prediction for which conic it might be? I don't know. Let's see what we find out. Let's group the x's and the y's. So we have 9x squared minus 72x. And then I have negative 4y squared plus 32y. Leave a space. I'm going to put this constant to the other side. It doesn't need to be there. And I could have done that earlier in the other equation as well, but we kind of knew what it was going to turn out to be. Okay, this means I have to complete the square twice, but I need x squared to have a coefficient of 1. So I need to factor out the 9 and the -4. 8x space -4 times y squared minus 8y space equals 64. Now I'm going to add what makes these perfect square trinomials. I know this is just 8 divided by 2 squared, so that's 16 plus 16. But that's not what I'm adding, right? I'm adding 16 times 9, which is 144. So I'm actually adding 144 there. And here, I'm not adding 16, I'm adding -4 times 16. So I'm adding a -64. So I need to add a -64, subtract 64 on the left side. Now we'll write these as as quantities squared. So 9 times x minus 4 squared minus 4 times y minus 4 squared equals 144. Okay, we still have 9 and 4 here, and we have some number that's not 1. Okay, this looks like it could probably be a hyperbola because we're subtracting. So your last step is to divide by 144 on both sides, which means dividing each of the terms. And we do indeed have a hyperbola. A for a hyperbola is always the first denominator, and so x is above a squared. A squared is the first denominator. X is above a squared, so this would be opening to the left and the right. That's what this hyperbola would look like. All right, that's shifted